Now we're going to look at simplifying some radical expressions. Simplify if possible. Our first problem is the square root of 12. To simplify, we're going to be looking for perfect squares that might be factors of the number underneath the radical symbol. For instance, when we look at 12, we know that that's equivalent to 4 times 3. We choose this factorization because 4 is a perfect square. We're now going to break this up into two radical expressions. That'll be the square root of 4 times the square root of 3. We can now evaluate the square root of 4 to give us 2. The square root of 3 cannot be simplified any further, and so we rewrite square root of 12 as 2 times square root of 3. Let's try the same process with the number 60. We're going to try to look for factors of 60 that would help us to simplify. Now, notice even though we can see that 60 is equal to 6 times 10, this is not going to help us underneath the radical in that format. Well, instead, if we notice that the first perfect square is 4, and 4 is going to be a factor of 60, we can use that in order to help us. We're going to rewrite this as 4 times 15. We can then break it apart as we did in our first problem. Rewrite square root of 4 as 2. 15 does not have a perfect square as a factor of it, so we're going to leave it under the radical symbol, and that answer is 2 square root 15. Now we look at the square root of 55. Now we know that 55 is equal to 5 times 11, both of which are prime numbers, neither of which, of course, is a perfect square. So for this reason, square root of 55 is as simple as it gets. Here are some more examples using radical expressions. This time we want to multiply square root of 3 times square root of 10. Because we have the same radical expression of square root, we're going to have square root of the product 3 times 10. This will give us square root of 30. Now, we want to think about whether or not we could simplify this any further. But in order to do so, we would have to have factors of 30 that would be perfect squares. But that's not going to be the case, so this is going to be our result. Here, in our next example, we have square root of 10 times square root of 10. We can put that under the same radical symbol as 10 times 10. That gives us a square root of 100, and the square root of 100 is 10. One thing to note in this example is if we have the square root of a number times the other square root of the number, we end up as our result the number itself. Finally, we have square root of 6 times square root of 2. This is going to be the square root of 6 times 2, which is equal to the square root of 12. Now in this case, we can take the square root of 12 and factor it differently as 4 times 3, separate those factors in the next step as square root of 4 times square root of 3, and then rewrite this as 2 times square root of 3 to get our simplified answer. In our next problem, we're going to look at division of radical expressions. Find the quotient. In part A, we have square root of 80 divided by square root of 5. We're going to begin this problem by rewriting this as a single radical expression where we have the fraction 80 divided by 5 underneath the square root. Next, we can go ahead and divide 80 by 5. That gives us a value of 16. The square root of 16 then equals 4. In part B, we have square root of 48 divided by square root of 6. We'll proceed in the same manner. This is the square root of 48 divided by 6. Reduce that to give us a value of 8. We notice that 8 can be rewritten as 4 times 2. And now we take the square root of 4 times the square root of 2 to give us our final result, 2 times square root 2. In the next example, we're going to look at addition and subtraction of radical expressions. Add or subtract as indicated. Part A, 8 times square root of 3 plus 10 times square root of 3. To accomplish this addition, we're going to note that the square root of 3 is a common factor. We can think of this as factoring the square root of 3 out of both terms. We're left with 8 in our first term plus 10 in our second term. We now are going to add the 8 and the 10 to give us 18 times the square root of 3. Another way to consider it is to realize that we have 8 of these expressions, this type of expression, 10 of that same type of expression, and 8 plus 10 is 18. Part B, we have 4 times the square root of 13 minus 9 times the square root of 13. In our middle step, we would think of factoring out the square root of 13 from both terms. We're left with 4 minus 9. We'll evaluate that to give us negative 5 times the square root of 13 as our result. C, 7 times the square root of 10 plus 2 times the square root of 10 minus the square root of 10. We're going to factor the square root of 10 out of all 3 terms. We're left with a 7 in our first term plus the 2 in our second term. And we need to make sure that we understand that there's a 1 that needs to remain in the third term so that if we multiplied back through, we'd end up back with that square root of 10. We now combine 7 plus 2 is 9, 9 minus 1 is 8, and we end up with our answer of 8 times the square root of 10. Here's another problem with addition and subtraction of radical expressions. Add or subtract as indicated. We have the square root of 3 plus the square root of 12. Now, since these radical expressions are not the same, we cannot add them together in their present format. However, we can note that square root of 12 can be simplified, and let's do that now. We're going to rewrite square root of 3. We're going to take the 12 and factor it into 4 times 3. We can then rewrite this as square root of 4 times square root of 3. That gives us square root of 3 plus 2 times square root of 3. We're now going to be able to factor out the square root of 3 from both terms. Remember, we'll be left with a 1 in our first term. We'll have plus 2 from our second term, and that gives us our result of 3 times the square root of 3. Part B, 4 times the square root of 8 minus 7 times the square root of 18. Again, in this problem, we note that we do not have the same radical expression. However, we also notice that we can simplify each of the individual radical expressions. So let's do that now. We'll have 4 times the square root of 4 times 2. Let's go ahead and rewrite our second term, 7 times the square root of 9 times 2. In our next step, we'll have 4 times the square root of 4 times the square root of 2 minus 7 times the square root of 9 times the square root of 2. And we can evaluate. The square root of 4 is 2, so we'll have 4 times 2 times the square root of 2. The square root of 9 is 3, so we'll have 7 times 3 times the square root of 2. And now we have 8 times the square root of 2 minus, here we're going to have 21 times the square root of 2. We now can factor the square root of 2 out of both terms. Leaves us with 8 minus 21. And now evaluate 8 minus 21 is going to be a negative 13 times the square root of 2 as our result. Our next problem deals with rationalizing denominators. Rationalize the denominator for each. We're going to have, in our first problem, 25 divided by the square root of 10. To rationalize the denominator means to rewrite this so we don't have a radical expression in the denominator. We can accomplish that by multiplying the denominator by square root of 10. We know the square root of 10 times the square root of 10 will give us just the value 10. But in order for this to be equivalent to what we started with, if we multiply the denominator by square root of 10, we also have to multiply the numerator by square root of 10. In essence, what we're doing is taking this fraction and multiplying times 1. We end up in our next step then with a numerator of 25 times the square root of 10. Our denominator, square root of 10 times square root of 10, gives us 10. We now notice that we have a common factor. We can divide both numerator and denominator by 5. Dividing by 5 in the denominator gives us a factor of 2. Dividing by 5 in the numerator gives us a factor here of 5. And so our final result will be 5 times the square root of 10 divided by 2. Now, one thing to notice is that this 10 is underneath the radical symbol. We cannot note that there's a factor of 2 under the radical that somehow would divide by this factor of 2 in the denominator. So we'll never work in that manner. Part B, square root of 2/7. We'll begin by rewriting this as square root of 2 divided by square root of 7. Then we're going to multiply by square root of 7 over square root of 7 in order to rationalize the denominator. In our numerator, we have square root of 2 times square root of 7. We can put those back under the same radical symbol as square root of 14. In the denominator, we have square root of 7 times square root of 7, which is going to give us a 7 as a result. And again, we cannot divide any further, so this is our final answer. Part C, we have 5 divided by square root of 18. Now, one thing we can do at the outset of this is to go ahead and simplify square root of 18. We're going to do that by rewriting this as 5 divided by the square root of 9 times 2. This will give us 5 divided by 3 times the square root of 2, where I've taken the square root of 9 and now multiplied times the square root of 2. And now, to rationalize, we're going to multiply just by that square root of 2 in order to get these to multiply together. The numerator becomes 5 times the square root of 2. In the denominator, we're going to have this product, square root of 2 times square root of 2, giving us 2. Multiply that times 3 to give us 6. And our final result will be 5 times the square root of 2 divided by 6.